So this is the second part of ROS model plugin where we'll talk about the advanced technique. So why advanced technique is used basically, and there are more than one ROS or Gazebo or a combination of subscribers are there. It can be combination of ROS and Gazebo, or it can be two Gazebo subscriber to ROS subscriber. Then to manage the thing properly, we need a concept of multi-threading in C++. So what is multi-threading? If you do not know, just check these videos out or check this playlist YouTube videos out. Also, to learn the things properly, especially about this plugin, you also need to know something mutex in threading. So you should also know this. So if you do not know this, please pause this video over here and check them out. As well as this entire understanding of this tutorial is based on a wonderful article on ROSQ. So I want you to check this out. You must check this out before proceeding further. So you must check all of this out. If you know multi-threading, and if you know, that's okay, but you should check this article out. So please pause the video over here before moving further, otherwise you are going to have lots of confusions. Okay, now let's move down. So let's discuss how a subscriber mechanism actually works. So what happens over here, whenever you receive a message over here, then there is subscriber queue got created, then callbacks queue get created, and then the function spins. So what happens, how it is represented in code is basically when you write the subscriber part of this, then the subscriber queue got created and it start receiving the messages. And what is this queue? Is based on a concept of first in first out. So this, once this has first entered, so it will go out first. Now the next part will come over here, same as this queue. These are all queues. Okay, so this is how it is moving. How this callback queue created, when you declare a callback, you define a callback. This callbacks actually get stored on this, and this get invokes whenever their turns comes. Okay, so this is what it is. Now this ROS spins. So this is continuously spinning because this process is continuously going on. So we define using a ROS spin. You see how simple things is there, but actually this is how implemented internally. So we do not have to define this by ourselves because ROS has described the simple function for them, like the subscriber, callbacks, and spin. So these are there for that, so that make the process easier for us. Now with this also comes a disadvantage. What is that disadvantage? Is that when you talk about a multi-subscriber, so what happens over here, like there is one subscriber, this got created. Once you describe the subscriber, then there is another subscriber. So there are two subscribers over here, and B is slower than A. So what will happen over here, that firstly B is processing. Now when B is processing and this spin is going on, when B is processing, then A has to wait for B to process. So this callbacks is actually stored like this values, this callbacks are stored of this particular function. This callback gets stored within this, for A stored within this, and B is stored over here. So B is taking slower, so it is taking more time to proceed than A. So what is going to happen, because it's first in first out, so B process will firstly end, till then A has to wait. So this is actually a disadvantage. So these are the disadvantages which are involved with using this simple function that ROS has been defined. So what ROS has done, if you want to define how your own callback will work, how your own spin will work, this how all the things will work, then you can use something concept of subscribers options. So this helps you to define your own. Otherwise, if you use a simple process, then you can just write like this, the one we discussed in the last video. Okay, but here we are going to discuss this advanced version where we'll be using the subscriber option, and we'll have the chance to define our own callback queues and this thing. Okay, so we are going to learn about coding of this using a block flow diagram. Okay? So this is that block flow diagram. So what you're seeing over here is that part what I explained right now. Now see it, I have divided into two parts. This subscriber thing is there, so this is the subscriber part of it, and then there comes the spin part of it, callback and spin. So these all are linked together. You will see in the process these all are linked together. So that's why I have drawn a diagram to give you a little bit better explanation. Otherwise very difficult to explain this part. Okay, Now let's see what subscriber option is doing. All the function details are I have already included in the website link. Okay, now here we'll just learn the explanation of it. So what happens whenever you describe the subscriber options? So this opens a door for you to define your callback queue and your spinner threading. Okay, so both you can define using this subscriber option. This opens a door for you to define everything in detail. Once you define this, then you can put it into the normal subscriber function that we already know. Okay, so this is that function. So earlier I used to take the topic and all the information. Right now it's taking the subscriber option. Okay, now let's see what is there inside this. So we are using create to create it, and we are using the callback message. Okay, so this template is actually the message of this standard boolean message that we are using. You might be knowing this from the last video. So this message we are using, that's why this is the callback message type. Now this is the topic that we have to give, and this is the queue size. This whole thing we do in the subscriber as well, but what's get new from here is this callback. So this callback is there, this bind is using this, you already know this. So this activate callback is there, that's going to have this activate callback over here. Now the next thing comes is void pointer. What void pointer does, it keeps a track on the subscriber. It keeps a track on the subscriber that whenever the subscriber values reference goes to 0, then it is going to cancel this callback. So you won't be able to trigger this callback. So this callback will be not available whenever this subscriber gets over. So that's what void is doing. So if its reference count goes to 0, then subscriber callback will not be called. So it will prevent it from calling it. Okay, after this is here, now there comes ROS queue. So that's basically not ROS queue. This ROS queue represent this callback queue over here. Okay, now what is doing, we have defined this data type as ROS queue, and we have entered this over here on the last part of it. That's basically, I told you this callback queue is there, first in first out concept that I have told you right now. Now here what we have done, that we have told him, okay, this is the part that is going to be this. So activate callback, this we are going to use, this void will be there, this queue will be there. Now this part over here. Now let's come to this part, how this callback and the spin is working over. Now let's see it from here. What we have defined, this is threading. So that's why I told you to learn the threading concept. This is completely using a 3++ threading concept. Okay, so you must know what is threading right now. Okay, so this threading is there. So we have defined a standard threading data member. Now using the standard thread method, what it's going to, we are going to put it a function within this. That function is going to be called within that thread. Okay, so using thread we can call many function at a time simultaneously. So if you call 3-4 functions, that they are going to run simultaneously. It's not like one by one, like codes runs now, one code then other code, not like that. It will be run at a time, so many. But as we are right now talking about just one, so I've written just one over here. Okay, so you can read more detail about this threading on this. So this function is start over here. This function that I've defined over here starts over here. What happens now, this checks, this is while this ROS node exists. So till the ROS node exists, this while loop is going to loop, and till this while loop loops, this spin is going to run. Okay, as soon as this while loop, whenever it happens, this ROS node doesn't exist, so ROS node ended up, then our thread is going to stop. Basically the function that is called over here, if this doesn't work, then it is going to come over here and it is going to stop. So if you remember, this same thing was done by ROS spin in ROS. So what it used to do, till this nodes exist, then it used to run, otherwise once the node end, it used to end that. This is what actually this line of code overdoing over here. Now the special thing on this is this ROS queue callback available. So this is a special thing over here that basically control this callback queue. Now let's see that you understood the structure from where we have come. Okay, now let's see this callback queue. this callback queue is there which is having first in first out. So I've expanded this to this. Okay, now there are queues are there on this. What is going to now happen? So this is working on first in first out. So it will first check is this callback is ready or not. What is mean by ready? And you will also see over available words like over here. So it's basically when so many thread is trying to use a particular function, then that function is stopped to use by many of them simultaneously using a concept of mutex in C++. We have to learn about this mutex as well, due to which what happens when one is using it that function, then it won't be available for the other. So basically this is a function, right? So whenever one thread is using this function, then other it won't be available for the other, because due to concept of mutex. Okay, so now what this line of code defines over here, it is defined in such a way that it will firstly check is that callback is available. It will check is it available, that callback. If it's available, then it is going to invoke our callback. So how this callback invokes, till now it's not invoked. When it goes to yes, it is available, this callback is available to use, then only we can use it, right? So now this will be invoked and we can use this callback and we can print our data and all those things and we can store this. Okay, if suppose this is not available, then what it will do, it will wait for some time. If this is not available, then no part comes over here, then it will wait for some time, otherwise it will directly push it backwards. What it is doing, it will first check okay, is it okay, then it will invoke the function. If it is not ready, then it will push it back. So what is happening over here is basically if this is available, then it's okay, otherwise you have to go this back. So one will come over here, and now this pointer came over here like this. Now if it is not able, then it is pushed back and it will check for the second. Even if second is not available, then what it will do, it will again follow this process. If it is available, then it will invoke it, but if it is not available, then it is again going to push it to the second. If now here the things become interesting. Even if it goes to third, then if it sees that none of the function is available, at least if it will check is there at least one callback available. If it is code yes, then again it will go over here and it will invoke this function. Okay, but if none of them is available, like it came from here, then it came to here, then it came to here, then it will wait for some times for at least one callback to get available. If one gets available, then it's okay, it is going to go back. If none gets available, after waiting for a time, that is called timeout over here, it wait for a time and it sees that none is available, then what it is going to do, it is going to return, means it is going to stop. So I hope you understood this process. So this is a very small line of code over here and it is working like this. This is how this big thing is there. So it checks it, if is it available, then it processes this, it invokes this function. If it is not available, then it pushes it back. Things happen with all of them. It wait for some time. If everything works okay, then okay, it's invoked. If doesn't, then it will return and stop. Okay, so this is pretty interesting part over here. Now if you see carefully, then what is actually happening, you see carefully, this spin, within this spin part is there, the spinning is over here, and this callback is actually controlled within this single line of code. This callback is controlled within this single line of code, that working on the basis of this logic that I told you right now. So you see, now you have defined this, and whole becomes this whole process. Okay, so this is how it is working behind the story. Now I hope you got everything from here. I even want you to at least once visit this flowchart and see the things, how it is defined, what is there, what is not there, and also have some knowledge of this concept of mutex and threading so that you can understand them better. Okay, now I've explained you the entire code over here. Now let's go back to our code and see in Visual Studio. Okay, all the detailing of how the function is there, what function is there, I've given over here on this. All document is there. So if you see, this are part from the previous as well, you know already this functional I have included to use the boost. This threading is there, so I can use the multi-threading in C++ ROS callback for accessing the callback queue, and this option for accessing the option. The coding part I have already explained you. Now this is there. Now one important thing is that in the last video we have declared the simple model plugin, so I have written a prefix like simple, but right now this advanced plugin I have just named it as model loss plugin. Okay, and these are the files that are being included. Now this is that same load function, but interesting thing over here is this ROS part. What is interesting over here is, you see, if ROS is not initialized, earlier what we were doing that if ROS is not initialized, just let's go back. But what we are doing in this advanced version, if ROS is not initialized, let's initialize a ROS node with this name. Okay, so you know already this. So this is actually a very good practice, so your code will never fail. But in this case, what it will happen, if it's not there, it will give a command and return, so your code will stop, this plugin will stop, right? Now once everything is there, we reset this using a new node. Okay, so this is resetted. Now this part of entire code is that subscriber option, then this so is put on the subscriber, and every detailing of this I've already explained you. This void pointer, this cross queue. For the explanation purpose, this code is not better. Take the flowchart that I have already. Okay, now this is there. Now threading is there, model stored, everything is same. This part you already know from the plugin, model plugin. Now this queue is there, which right now I explained you. This is that controlling the pinning and this callback function, callback queue. Okay, so this is called controlling the callback queue. Now this activate you see this code is exactly the same. The activate callback, this callback function is exactly same. On update is also exactly same. Only thing that was different over here is that when we are creating, we started as a unique pointer. We define as ROS node as unique pointer. We define the raw a callback thread, ROS callback thread, and we define the threading. So these parts are new, and this whole code that I have explained you right now, these things are new. These things are new in this advanced version. Otherwise, in the simple version, it was very simple. Okay. So I already told you the benefit of this. You will have a better control on your callbacks and queues. Okay, so this is pretty much that code. Now let's check this, is it going to run or not. So this will go on over this, and the first one was for simple, but the more advanced one, as I already told you, I have just named it model plugin ROS. So we'll copy this and we'll launch this. Now this is launch, our model is here. Now we'll copy this to publish as well. Exactly the same thing that we are, from the outer perspective it seems like a same thing, but if you go on detail you will understand that you have a better control over here, right? So this will work for some seconds and it will come down after this count goes to 10,000. Now it is come back. Even this callback was invoked, so one is message is received. All the things are same, just that this advanced version has this difference of using subscriber options. So you will see that in mostly the ROS Gazebo plugins, this method is used, not this simple method. Okay, so when you check your actual code of Gazebo and ROS plugin, Gazebo ROS plugins, that is written by the developer, the official developer of this Gazebo, so they have used this option. Okay, so that makes it very important. I hope that all the explanation are pretty much clear to you. So that's it in this video, and do check this diagram out. Okay, you must check this diagram out and all the things that I've told you. That's it in the